So in today's video, we're going to be looking at linear functions and also its examples. So I know when some of us hear the word linear functions, we just assume there's still going to be those ones that are still at your high school or your college level. I also had that type of thought until I started sitting down and doing this type of examples. So you will see as we go along that they can sometimes do get tricky, but I will just teach you everything that you need to know when it comes to this chapter so that you will no longer have confusions. So example 1 reads, in 2005 the population of a city was 3.49 million, and in 2010 the population was 3.7 million. So question 1 says find the formula for the population P in millions as a function of time, T in years since 2000. Assuming that it is a linear function, then they say you have to interpret your slope and also you have to do your estimates in 2020. So first things first, since they've mentioned that you have to assume you're going to be working with a linear function, so you know that your linear is given in which form? Your linear is given in the form your y. Let me rather use a different pen so that you guys will be able to know. You know this, it's your y is equals to your mx plus your c. Then with your m, you know this one, it's normally your slope. Then this would be your vertical intercept. You see? So that's the slope for your linear function. And what else would the interpretation of this be like on your Cartesian plane? So if you have your Cartesian plane like this, remember here you have your y values and here you have your x values. And we know that the values that are here, these ones, we know these are the dependable variables. Then these ones will be your independent variables. So now we go again to this type of question and ask yourself, since they're saying find the formula for the population P in millions as a function of time, so what does that statement mean? Let me just highlight it, this one here where they say P as a function of time. When they're saying P as a function of time, basically they're trying to let you know that we have your P is equals to f of t, and between your population and your time, which one would be depending on the other ones and which one will not be depending on the other. So you know the population would definitely depend on time for it to grow. So it basically mean here you have your population, then this side you have your time. So time doesn't depend on population, but the population to grow depends on time. You see? Then now coming back to this equation that you have, how do you find your m, which is your slope? We know our m is given as our change in y over change in x. You see? So now it means if we have to work out the slope for this one, we will have change in population over change in time. So that's how you work it out. So we know if we're going to write this one further, we're going to write that y2 minus y1 over x2 minus x1. Then for this one, we are going to write it in which form? We're going to say we have P2 minus P1 over T2 minus T1. So that's basically the interpretation for that part. So now it means since we were able to work this part, now we have to definitely come and find that M. So we go again and try and read so that we can be able to determine our P2, P1, T2, T1 in order for us to be able to calculate the gradient. And we know if we can be able to calculate our gradient, which is our M, we can basically use 1 point to find our C. So where are exactly those points? Because they have to be somewhere here hidden within the question. So if you can go and check carefully, we do have this one, which is your 2005, and we also have this one, which is your 2010. So those are the ones you have to pay attention to, because they say in 2005 the population of the city was 3.49 million. So meaning we have to also underline this one. Then they say in 2010 the population was 3.74 million. So now you see that we actually can say we have the first point as what? As 2005 and our 3.49 million. Then the second point, we can say we have the 2010 and the 3.74 million. But that's not all. There is one key thing that you have to note and also check for in this type of question. You see, they said find the formula for the population P in millions as a function of time T in years since 2000. Since 2000, what does this mean? This is basically our reference. This is what we are going to be referencing from. In other words, they're trying to tell you that this 2000 that you're seeing here, this is our T equals to 0. So when you're going to work your time, you're going to work your time referencing to this one. Like for instance, now you will have your 2005 minus your 2000, then this will just give you 5. So you can even write this one as a 5. Let me check. Oh yeah, you can write this one as 5. Write the point like this. Remember, now I'm trying to write this points in a much cleaner way, or in a way that it doesn't include much bigger values. You see, because if you're working with bigger numbers, it becomes quite tricky to work your equations and so on. So now I said, okay, we're working with reference to this one. We said 2005, then we deducted the 2000, we get our 5, then we have this 3.49. so remember they said this is 3.49, so we can actually divide by a million, because they said P is in millions, they've stated here. It means now we can actually have what? We can have this divided by a million. Basically you have 3, 4, 9, 1, 2, 3. Then we divide it by a million. Then this is going to give you your 3.49. So meaning here, the point that we're going to have, we're going to have 5 and 3.49. So now same thing comes to this one. You're going to say you have your 2010, then you deduct your reference year that you're going to have, which is 2000. In this case, you will say 2010 minus your 2000. This will give you your 10. Then remember this one, since they said it's in million, you just divide this one by a million. You will say 3.74 00, then you divide it by a million, then it's going to give you your 3.74. Then what do we have in this case? It means now here we can say we have our T1 and P1. This side will say we have our T2 and P2. So yeah, I just hope you guys are still on track, because I have less space to work on, and also at the same time try to keep all the information on the board for you guys. So yeah, as I said, we have our T2 and P2 worked out here. And one thing I would like to emphasize is that you don't always have to do these conversions that I like the way I've done them. Like in this instance, the only time when you do them like this, which is the second step that I did, it's when you are having your references 0, if you're having t is equals to 0. But if, let's just say for an instance, you had a reference time that was greater than 0, please just use this format, because you might make mistake. Even though you are going to be working with bigger numbers, it's just going to be much safer for you, or for a lot of students, to avoid making mistakes. Because even if you use this one, you're just going to still get the same gradient as the one that we are going to get when we use this one, which is simplified. I chose to use this one because when I'm going to do my calculations, it's much cleaner. So it's a thing of preference. But the main major thing that I want to emphasize, please check your reference if you want to use the method that I'm using. So now that we've highlighted those, I think we are ready to do the first one. So as we said, our M, which is this one, we will have our P2 minus P1. Then what would that be? What would that look like? Remember, here we're going to be solving number 1. What did they say? They said you have your P is equals to your f of t. But we know, what do we know? We know that your P is equals to f of t. This is the same as having your mt plus c. Where do I get it? Remember, now we are not working in x's, because I see one another mistake that students make. They forgot that we're working in t's. Remember, t's are the ones that are going to be in your x-axis. Even when if you're supposed to draw this, you will know time is represented in t, then population here is represented in p. So don't come and write mx plus c. You are not working in x's, but rather your t's. So that's why you see here I've written the t. So that's one highlight to note. So now we will calculate our m and say, we said our m is change in population over change in time. And we've stated here that we're going to have P2 minus P1. Where's our P2? Our P2 is here. That's 3.74. We have 3.74 minus 3.49. Then we divide this by T2 minus T1. We have our 10 minus 5. So this is going to give us how much? also just try to, oh yeah, this is going to give us our 0.05. So now, okay, they said find the formula. Oh, we actually have to find the full formula, not the gradient only. So now what we are left to do is that, okay, we have what do we have now? We have P is a function of time. Then we have this one, 0.05 T plus C. So this is currently the function that we have. So in order for us to have a full function, we can either use this point or this point to find our C. So remember, this one we can just say is the same as having your y is equals to your 0.05 T plus C. You see, then now we know that your y, it's your P, then your T, it's your time. So if we go and plug one of the point, any of the point that you would like, you can use this 10 and 3.74. You go and check, okay, I have my T2. What's my T2? T2 it's X, then P2 it's my Y. Then you come and say you have you will say you have your 3.74 is equals to your 0.05. Then your T, this will be multiplied by 10 plus your C. Then you will find out that your C will be how much? Your C will be 3.24. Your C will give you your 3.24. So now you can go back and write this formula since you found this C here, that now you have your final function as 0.05 plus T plus 3.24. So this would be the final answer for your number one. So I just hope that was clear and everyone understood up until this point. So now we're supposed to interpret the slope of the linear function. Where is the slope? The slope is this 0.05 that you got. So basically now, if you take this 0.05 and multiply it by your 1 million, this is going to give you your 50,000. It's going to give you 50,000. Let me just do it here, that okay, you have number 2. I'm just trying to explain it first. You will take this one, you multiply by this million, you are going to get your 50,000. So what does this mean? It means the population sorry about that. The population grows by 50, by 50,000. The population goes by 50,000 people per year, but you're just going to write it in a full term, or you can just say the population is growing constantly by 50,000 per year. Even that one is still appreciated. So now they say estimate the population in 2020. Remember, now you have this formula that you are given. So now what you just have to do is to input that 20 into this equation, because as I said, since we are referencing from this one, If you take this 2020 and then you deduct this one, you are going to get your 20. Or the quicker way to do it is that, okay, if your t is equals to 0, you always take the last two digits of your numbers. You see here we have 05, here we're going to have 10. Then even if you want to verify, you can still take what you have, then deduct this. Take what you have, then deduct this. You'll still get your 10 and your 5 and the 20 that we're working here. So now it means we have to work our P is equals to our F of 20. Then this will be the same as having 0.05 into 20 plus 3.24. One thing that you should note about calculus is that after getting your answer, please make it a habit that you do your conclusion in weights. So you write that you got this answer and this answer means this and this. So they like to also award maybe half mark for that one also. So this is just to make sure that you get your full marks when it comes to this one. So now your estimation, you're going to do this, and this will give you something like your 4.24. So now your conclusion will be what? Since I don't have space at the bottom, your conclusion will be the population in 2020, it's 4.24 million. And that's basically how you do this type of question. So I will just like leave you guys with one bonus question to do on your own, and you guys will comment with the answers that you found. So yeah, this is the bonus question that I'm leaving you guys with. So we have two tables that are given. So you have to determine between table A and B which table represents a linear function, and also to write the full formula of the function. You can also do this in the comments, and here I've given you guys a hint that the values of x and y in a table represents a linear function. Y is equals to your mx plus b if difference in y values are constant for equal difference in x. So yeah, I know maybe some might still be confused. So basically with this one, what you just have to find, it's your m, which is your gradient. You remember we said this is your change in y over change in x. Even this, if it's written as rt, this will always be your x, this will be always your y, but it means now you're going to have change in t over change in r. Here it's written in a normal format. You're going to be having your change in y over change in x. You try and find the slope. If the slope is constant, you're getting a same answer, then it definitely means that that table represents a linear function, because you are getting a constant slope throughout. But if your slope is changing between the points, it actually means that table it doesn't represent a linear function. So how are you going to find the function if you can't spot the points that you're going to use? How do we group them? We can actually group them by using a column. So you can have those ones that will go with these ones. So you can just say this would be your point A, this would be your point B. So what is going to happen between your point A, you are going to say you have what, which one is your x. Remember here you have your x, this one represents your y's. you always have your x, y. So you will say you have your 2 and 3. Then when you come to this side, you're going to say you have your point B, you have your 4 and 5. And as I said, this is your x, this is your y, this is your x, this is your y. Then you can decide that this would be your x2, y1, no, y2, sorry for that, y2, no, not y2, y1, y1, x1. Even if you make this one your x2, y2, then x1, y1, you're still going to get the same gradient. So you repeat this one. So remember, here we have your a, b, c, d. So you can try and find the slope between a and b, and you can also try and find the slope between b and c, and also between c and d. And if you're still getting the same slope, it would mean it is definitely a linear function. So you will do the same with this one. You can group this one together, and also you can group this one together. Then you can also group this one together. I'm not saying that the red you can also do them with the red. I'm just saying you use this as point A, you will use point A and B, then you can use point B and C, or C and D. That's the main issue that I want to highlight. Then you will tell me between these two which one represents a linear function and which one doesn't, or if they both represent your linear function. So yeah,